Okay, in our last little short video, we introduced the idea of the standard molar volume. That was a direct outcome of Avogadros Law, which states that the volume of a gas is directly proportional to the number of moles. So whenever we are at STP, that is standard temperature and pressure, that is the temperature is 0 degrees Celsius and the pressure is 1 atmosphere, we can very easily calculate the number of moles based on a volume or vice versa. And so that becomes useful, for example, when we're doing gas stoichiometry problems like the following example. So ozone has the formula O3, absorbs UV light, and it is decomposed into oxygen gas. So if we initially have a sample of ozone that is 5.46 liters at STP, how many moles of oxygen can be produced? Okay, and so the first thing we need to do here is write a balanced chemical equation. So we have ozone gas absorbs UV light to become oxygen gas. And so we are going to have a simple balanced equation here. Okay, and so this says that 2 moles of ozone produce 3 moles of oxygen gas. So to calculate the moles of oxygen that we can produce here, we are going to use Avogadros law and the standard molar volume. So we're going to start off with our volume, 5.46 liters of ozone. We know that 1 mole of ozone, or any gas, occupies 22.414 liters. And then, so this will give us moles of ozone, and now we can convert this to moles of oxygen. 3 moles of O2 for every 2 moles of ozone that reacts, telling us, looking at my calculator here, so we have, we'll clear this, 5.46 divided by 22.414 liters times 3 divided by 2 tells us we have 0.365. So 0.365 moles of oxygen being produced. Okay, now as we are converting between ozone to oxygen, we're producing more moles of gas. So initially we had some number of moles. As we convert that to oxygen, the number of moles increases. Okay, so if we're in an expandable container, such as a piston or a balloon, okay, this container is going to expand. It's going to, the volume will get larger, and so we can calculate the standard molar volume. Here, really, it's going to be the ratio of moles here, because we're going to take this 0.365 moles of oxygen now times 22.414 liters per mole. So we can see right away that really our factors of our standard molar volume are canceling here. But what we get here is really the initial volume times our stoichiometric ratios, 3 moles of oxygen per 2 moles of ozone. So we take this number 0.365 and we multiply it by 22.414 to get our final volume, and we see that our volume increases from 5.46 to 8.19 liters of oxygen now, which is really just 5.46 times 3 halves. 5.46 times. Okay, so that's one common way that we use these standard molar volumes to very quickly assess the increase or decrease in volume in a gas phase chemical reaction.